the word garbage is typically construed as something that is no value. It's all about understanding what value you can create from it.
Hello. Welcome to the Good Garbage Podcast. My name is Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? Sunder and I have been friends for a few years now. We have consistently prioritized his solutions for our packaging in the company I work for. He has been a frontrunner in the biopolymer space in India, and I have witnessed his progress from the ringside. Sunder has the mind of a scientist and is constantly evolving possibilities. He has also transformed himself into a business leader, not just growing NatureTec, his company, but also spearheading the Bioplastics Association in India. I get to know him more through this conversation and leave even more inspired than before. This is a story of grit and hope, and I'm sure you will enjoy it as much as me. Hello. I'm so happy today to have Sunder Balakrishnan, the General Manager of NatureTec India. And Sunder and I have been friends for a few years now, Sunder, right? So I'm so happy that we could find time and you can be on the show. So thank you for taking this opportunity up in short notice.
No, my pleasure, Ved. It's always great to connect with you. I think we both share very similar ideologies and probably, look at sustainability in a very similar way. Probably different angles to it, but then it's always great to chat with you. It's been a pleasure. Yeah.
Thank you, Sundar. So a few things we haven't talked about in our years of knowing each other is tell me more about growing up and influences there, and maybe there are some influences early on that impacted your journey.
I'm obviously from Chennai. That's where I come from. So been from a very conservative Tambram family. Incidentally, my dad was probably the first one in his family to actually start a business. In the 80s, it was very unheard of in his family for someone, because he had a job. He had a full-time job and he wanted to come out of it, and he started his business in the area of leather chemicals. 84 is when we actually started a company. I've really grown up kind of, seeing him, how he does the business, how he works with people, and it's been a lot of inspiration for me personally. I know I also follow a lot of what you do, and you've said a lot of things about how your dad has inspired you as well. So I would say that's been a real starting point for me in my life. I always wanted to do something related to chemicals, primarily because that's what I saw my dad doing. Until I realized that when I got into chemical engineering at ICT Mumbai, it was nothing actually related to what I what I had in mind. I think that's kind of how I've really grown up, seeing my dad, and yeah.
Just for the benefits of the listeners, we, of course, you and I both understand the anecdote of Tambram and typical Tambram, but I know that the listeners will be from all over the world. So, of course, Chennai is in India, that I can specify, but you'll be much better at explaining what does Tambram mean.
Sure. So Tambram is actually, Tamil Brahmin, which is basically, Tamil is essentially, as you know, the language we speak in the local state of Tamil Nadu, from where I come from. And Brahmin is kind of a certain subsect of a Hindu religion. Typically, Chennai is very known for Brahmins in the earlier days, when they used to deal, especially with professions like medicine, law, used to have a lot of Brahmins who kind of used to follow through on some of those professions. And I basically come from that background. So that's what Tambram is really.
And you're being very humble. I would go further to say they are probably the biggest brains in the country of India.
I
And also, like you said, there is a certain conservatism that comes along with that sect of people. So you mentioned that early on, but I would definitely say they are well known for their capacity to study and to come out with new ideas as well.
Yeah, absolutely, absolutely true. That's
So,
true.
of course, you explained chemical engineering and it came from your dad, but you could have just joined the family business. Why did you decide to go to Michigan State, pursue a PhD, meet our common amazing friend, Dr. Ramni Narayan? How did you get onto that bandwagon?
So as I said, I've grown up seeing how my dad works, and probably I always wanted to do something where, which was very entrepreneurial. I've always felt that urge to do something on my own, something entrepreneurial. That's always been there. And when I went to Michigan State, obviously, I think meeting Dr. Narayan, who I incidentally also know through my dad's contacts in Mumbai. So Dr. Narayan and his wife and my dad had a very common friend circle. When I went to Michigan State, I was able to understand from Dr. Narayan, especially the kind of work he was doing. And in those days, at least in Michigan State, what they used to have is you have to fill out like your choice of your PhD advisor, and there was three choices. Typically, they give. So I had Dr. Narayan as all the three choices, and and they were like, no, no,
Now I know why you are this blue-eyed boy, Sundar. He
no.
talks so much about you.
I was so inspired when I met Dr. Narayan the first time. What really felt really good, and I was able to connect, was he was very entrepreneurial as well. And somehow I wanted to do a PhD, but I was like kind of really concerned whether is it going to be like sitting in the lab and doing things, or is it going to be more out there developing products, taking things commercial. And then when I met Dr. Narayan, I found out that he was the right person, because he himself was running so many different companies, launching so many new products, working with so many brands. So I thought, okay, and then I just couldn't find anyone else who I could work with. So I put everything, Dr. Narayan's name. And I think that was kind of the beginning for me to really, get inspired and be a part of this journey in the area of bioplastics for the last, I would say, 20 plus years. Yeah.
And what was the thesis on? Did you focus straight away on biopolymers, or was it something else and then you meandered into biopolymers?
So it was into biopolymers, but interestingly, I think Dr. Narayan has a very different approach in how he runs his graduate students, his programs. A lot of the times, professors typically they define a project, and you're expected to kind of run all the project as per whatever is the real pathway to the project, and then you put in a you file a pre thesis, and then you go and do your final thesis. With Dr. Narayan, it was very different. For the first few years, he just had me work on different stuff. He said, work with this equipment, work with that, work with this company, and he was giving me so much of freedom to do. So I just used to apply for a lot of conferences. I used to go. I started reaching out to companies where, and this was in my first year, writing proposals and finding out if Dr. Narayan can write a proposal to this company and get some funding. So doing all these things. So for about 2 years, I was just dabbling on a lot of stuff. And at the end of 2 years or 2.5 years, I was starting to get a little concerned. Like, it's been like 2.5 years. All my colleagues from India had kind of already moved on, and they're like, all of them are talking about pre-thesis and submissions, and I'm like, I'm not sure what I'm doing. But then Dr. Narayan was like, he said, don't worry, Sundar, you just like keep focusing, and don't worry, your thesis will join. You're doing a lot of stuff, but it's just that you have to connect everything. And then very beautifully it got connected in the area of reactive compounding of biopolymers, because I was doing a lot of reaction chemistries. I was working on compounding, working on different applications, and then it got so easily connected. And then it was all about just in a few months kind of bring everything together, fill the gaps, and kind of go forward. So it was a very very different approach. It involved a lot of trust between Dr. Narayan and I in this process, which I today understand that in the PhD program, it is so important to build that with your advisor. It's a journey, it's not just that you go get a degree and you come out of it, but I think it's the process of the things you learned, all the points where you do errors, you make mistakes, you end up doing a lot of this during the PhD. And then it's about kind of coming out of it and saying, okay, here is what this is what makes sense. So it was a great journey, and I think I learned a lot from Dr. Narayan in this process. So
Yeah, I guess you got a PhD and a training in entrepreneurship alongside. Well, I guess you had some from your father, and then
yeah.
further, just kind of trying to do other stuff. So, did you jump into being an entrepreneur right after your PhD, or did you kind of work somewhere? What was that transition like?
So as I was doing my PhD, the present company I'm working with, Northern Technologies, where NatureTech is a division of, they actually visited the CEO of that company, Philip Lynch, and his team had visited Michigan State to actually connect with Dr. Narayan and do a project. And so through Dr. Narayan, I was able to get an opportunity to work with them on a summer project. At that time, the CEO had come back to me and said that, yes, if you're interested, you could come and join us once your PhD is over. And so that's how I got involved with Northern Technologies, really. Yeah.
And why did you not decide, like a good South Indian boy, to stay on in USA? And you decided to come back and tackle the craziness of India, and that can't be easy. I guess it may have been a decision that you already had in mind, but how did that happen? Why did you decide that you're going to tackle things in India, which is not the easiest of markets?
Yeah. So what happened is, after I did my PhD, I actually joined NTIC, and at that time, I was initially working as part of another business division, which is into corrosion management, uh, you know, corrosion inhibitors, and that kind of a business. And at that time, NTIC was actually looking at an opportunity to start the bioplastics business, and India was one of the potential markets for starting this business. And at that time, NTIC was actually joint ventured with the TVS group here in India. And incidentally, the JV of that company was also in Chennai, headquartered in Chennai. So I felt, and they were looking at someone who could, come and kind of, grow the opportunity of grow the business in India. So I thought it was a good idea to come back, because I had always in my mind to come back to India at some point. I wasn't just sure when it would be, but when this opportunity came up, and I was surprised that the JV was also in Chennai, the very city I am from. I felt that this was a good opportunity, and I kind of decided to come back. So it was more of a joint decision between what I wanted to do, but also the environment, the situation was such that it helped me make that decision. It was a lot more easier to make that decision. So
And I'm sure your family must have been delighted with that decision, that the prodigal son returns finally after so many
my
years.
family was very happy with the decision, and I did find that now after 20 years, I feel that I I I feel that I made the right decision. Of course, every decision comes with a lot of consequence. I mean, a lot of I would say positives, negatives, and that's something that we, as long as we accept it, it's good. Maybe if I would have been in the US, I would have had a very different career path to what I'm doing now. But whatever it is, I'm happy with the decision. I'm very happy and at peace with what I'm doing now. And so that's kind of what it is.
Sundar, tell us more about this company that you mentioned, NTIC, which is the mothership. And as far as I know, they are more of an anti-corrosive kind of company. So, what is it? What motivated them to get into biopolymers, and how did that become part of their portfolio?
Yeah. So NTIC basically is Northern Technologies International Corporation. NTIC is one of the leaders in corrosion management. Like, we have a brand called Zerust, which is stands for essentially zero rust. The company kind of started working on corrosion management solutions way back in the 1970s. The founder of the company, Philip Lynch, was someone who has always looked at technology as a very core platform to innovate and grow businesses. And when I joined NTIC, they were looking at a lot of technology platforms which could potentially, grow the business. And NatureTech was one of them, and that's how they got into NatureTech, because they were connecting with Professor Narayan, and so that's how they got into NatureTech. But essentially, we are a technology company focused highly on innovation and product as a company, and that's how we also got into other areas. Like today we have the corrosion management not only for the automotive business, but we also have a business in the oil and gas space where we are looking at corrosion management solutions for storage tanks, pipeline corrosion. So there's a lot of work going on in the oil and gas space, and there were other technologies also being evaluated at that time. So
Yeah, because I remember in the pulp and paper business, and I presume it may be similar, it used to be VCI coatings,
yeah,
and I don't know the full form of VCI, but yeah, some kind of
yeah,
anti-corrosive kind of applications they used to do,
yeah,
especially, actually, lots of it went into the automobile component kind of
yeah,
wrapping. And there used to be specialized companies, I'm sure you know our common friend SafePack,
yeah,
and they were very heavily into
sure,
VCI coating
sure,
at one point. It's a super interesting application for sure, and I can see the correlation between
yeah.
those two because they're kind of emulsions in the end.
What I came to know, and I was not directly involved in this, but there were a lot of customers in the late 90s, early 2000s who NTIC was working with in the automotive space. They also wanted to understand if they could get anything which is more responsible in terms of environment. I mean, any materials. So at that time, because even today, majority of the VCI based packaging materials is still based out of conventional plastics. Yes, you could do coatings on paper. That could be one, like what you rightly said, or you could have solutions where you look at oil-based coatings or water-based coatings, which could be put on paper, which can also give that kind of a corrosion protection property. But majority was still conventional plastics. So there had been a lot of interest in the past, especially from companies who are looking at switching into more environmentally responsible options, and that was also one of the triggers for why NTIC decided to get into this space of nature tech.
I'm going to pick your brains a little bit because as you were speaking, the term acrylics came to my mind. And of course, typically, and when you're saying it's mostly petroleum based, even the VCI coatings. So, what does the term acrylic mean, and how does that apply and connect? And then they call bio based acrylic, and what does that mean? I know I'm taking you off on a tangent, but I wanted to learn that area
Sure,
while I have you
sure.
here on the screen.
Yeah. So acrylics are typically polymer-based systems. You could have something like a polymethyl methacrylate, for example. It's one of the acrylics which could be used, and they provide certain properties in terms of depends. Like they could provide a certain barrier property if you want to look at water vapor barrier, oxygen barrier, provide properties of sealing. They could help you seal materials. Oil barrier, grease barrier. So they are typically polymer based systems. Now, these polymer based systems have to be deposited on your product, which could be, let's say, for example, it's paper. And these systems are now dispersed in a medium. For example, you could say water, which could be the dispersing medium. And this medium kind of takes it and deposits these polymer based systems onto paper. And then the water kind of evaporates. So that's why you call water based acrylics. And then if you're looking at bio based, a lot of these acrylics, the source of the carbon in that material, majority comes from a petroleum feedstock. But if the source comes from a renewable feedstock, then you can call it as a bio-based acrylic. There's a lot of bio-based chemistries in the acrylic space, but even in the thermoplastic elastomer space, there's a lot of bio-based chemistries today, where you could look at, let's say, a polyol chemistry, which could be a bio-based polyol. So instead of getting it from a conventional carbon source, you're getting it from, let's say, a soy-based system, or any system where there is a renewable component involved in it. And so these bio-based acrylics are becoming more relevant now, especially considering that companies want to reduce their carbon footprint and move into a more carbon neutral economy, these bio-based systems add a lot of value in that way.
And they could be both bio-based and compostable, like a PLA. Or it doesn't have to be just bio-based in terms of acrylics as well.
Usually, at least to my knowledge, acrylics are usually just bio-based. Typically, when you look at a lot of these properties, right? I mean, typically acrylics are more used for durable applications as well. And in those applications, you don't want to engineer compostability as a product functionality into it. You want the material to be durable, you want it to perform, you want it to take it through the process, the application, the time span, the entire lifespan of that application. And so engineering bio content is probably a better value proposition than engineering compostability.
Okay, I'll get off my tangent. I might come back to it again
Okay.
because this is this has been something that I've been pondering on the acrylic space. But why PLA for NTIC and for you? What was it about PLA that attracted you guys? Why not something else? Why not a PBS, PBAT, or a PHA even? What made you focus so much on PLA? And in the years I've known you, you've kind of stuck to that gun. It's the PLA space that you're playing in. So, what is it about PLA that attracts you so much?
So first of all, I think as NTIC, we, at least as on today, we are very agnostic to our material chemistry. Yes, we do focus a lot on PLA, because it's one polymer which is both bio-based as well as compostable. I mean, it's 100% bio-based and it's also compostable. But having said that, as NTIC, we do have a lot of, our core is developing reactive chemistries around bioplastics. So yes, today we do work with PBAT, we work with PBS, we work with PHAs, we do work with a lot of biopolymers. PLA could still be a significant component of this entire mix. But having said that, we do work with other biopolymers as well. Our core expertise really is coming down to developing applications using reactive chemistries of biopolymers. And here is where a typical compounder in the true sense of a plastics compounding industry is a machinery which is used to mix one or two components. Typically you could look at mixing a plastic with a filler, or certain chemistries that could potentially you could do. um, Here is where, at NTIC, we've kind of taken this equipment and converted it into a reactor. So today, most of the reactions that typically happen in a batch scale reactor, and for us, a reactor is usually, we envisage a reactor as a vessel where it's got something going in, you do some mixing, and something comes out. So here, this compounding unit, from where you feed something, there are a couple of screws which are rotating, and then you get a product out. That unit is now being used as a reactor. So a lot of chemistries which we do in terms of building bonds, grafting, dispersing certain chemist fillers into the product, happens in that residence time in that equipment. And all our proprietary position is on that system of that process and the formulation around making a certain uh, product, which can then be used for developing applications in different spaces. So really, the key that we have been trying to do and we have been working on is using the extruder, the compounder, as a reactor, which could give us lot of variables and options to work on reactive chemistries around these different biopolymer systems.
Yeah, and I think your technology, if I'm not mistaken, it's called REX,
Yes. Yes.
the NTIC technology. So tell us more about this. What is it, and how did you evolve this? And what is so special about it? Does it give you more homogeneity? Does it a better mix? Is it a wider array of polymers that you can work with? And as much as you can kind of guide on, what makes it different from others? Why is it so proprietary?
Yeah, see, essentially, if you look at the biopolymer value chain today, I want to take it a step back here. you have all these base polymers. So you have materials like PLA, PBAT, PBS, and each of these materials have they fall into a certain functionality space. So for example, PLA, if you look at it as a material, it's a very brittle polymer, and PBAT is a very flexible polymer. So yeah, there are a lot of applications where you would want to combine the properties of both PLA and PBAT. So that's the first thing. Is what I'm saying is there's no one biopolymer which is kind of a silver bullet here. So you need to look at how do you combine different materials. So that's one. Now when you talk of the compounding part of it, um, the compounding, that whole equipment gives a lot of features that allow us to do these reaction chemistries. So if you typically look at a compounder, you've got a feeding zone. You can do something on the side zones. You can add liquids into it. You can add catalysts into it. You can pull out vacuum. You can remove moisture. So it's such a beautiful unit where you can really play around a lot with the chemistries you can do in this unit. But more importantly, the profile of the screw inside. And typically it you talk about a lot of the mixing that happens within the unit. The second is you can also control how much time you want a reaction to happen. Depending on the speed of the screw, the type of screw, you can actually decide how much of reactions you want to happen, what is the residence time you want to give. So there's just so much of flexibility as a unit. And I think that's what NTIC, we've been able to kind of leverage that with the knowledge of materials and applications.
And over time, I've always learned that the devil is in the detail, right? And it matters so much. I remember when you were talking, I was just remembering like 25 years back or something. It was a simple consistency controller. But just because we didn't have the right distance between a sensor and a
Mhm.
controller, it would not function.
True.
It was just a matter of a meter, right?
Sure.
But you
Sure.
needed 3 meters, and you needed ideally a horizontal space instead of just a vertical
Yeah.
space. But that's what happens, right? You don't get the nuances right,
Yeah.
and then it might malfunction for a long, long time. So I can imagine how much effort it must have taken to evolve something that can be so flexible. So that's interesting for me. I always thought you to be very, very focused on PLA, but it's a lot of different products then. So let's move back to your journey. So, okay, you come to India and tell us in broad strokes, what has that journey really been like? And what is it now, 5, 6 years at least or more?
No, it's been so 2025 will be my 20th year in India.
In India?
Yeah.
Ah, okay, okay, my bad then. So okay, so what is that? Give us a short synopsis on what that 20 years has been like in terms of the journey, especially because you were so early and so new in the biopolymer space in India.
Yeah, it's been with a lot of ups and downs, I would say. Obviously, when you come in, and as you rightly said, in 2005, when NatureTech was started, we were the second company in India to get into the biopolymer space. So the first company was a company called Earth Soul in Bombay, and they had I believe at that time they had some tie up with this Italian company called Novomont, and so they were selling into all the hospitality space, because I see a lot of I used to see a lot of Earth Soul products in hotels like Taj and ITC and some of those large chains. So in 2005, when I moved back to India and we started NatureTech here, we really trying to understand, what's the best application fit for this product. And at that time, I would say a standard pricing for a film product like a carry bag or a garbage bag would be about close to 550, 600 rupees a kilogram. So really speaking, the alternate was a conventional plastic, which was at 120, 130, 140 rupees. Unless you could really look into creating that value, there weren't too many takers, and the legislative space was also very undeveloped. So in 2005, there was no standard for compostable plastics in India. And what we realized was that this industry required a lot of policy drive, and for which you needed to work with the standards body, you needed to work with organizations in the government like the Ministry of Environment, the Central Pollution Control Board, uh, at that time, CIPET, even today, and the Department of Chemicals, Petrochemicals, it's DCPC. A lot of my initial days at NatureTech, I did spend considerable time in trying to understand the nuances of how these different kind of entities operate in India. And thanks to, at that time, we were joint ventured with the TVS group, as I told you. Definitely it helped a lot because we definitely did have a lot of network through the TVS group that we could use potentially, and go and understand and talk to these different governments, and understand what's going on. And then it was all about working with BIS and creating the standards, and going through the entire process of how do you build certification schemes around it. So this was, I would say, a good 3-4 years I spent in looking at this kind of roadmap for the industry as a whole. And then the opportunities, like in 2000, I would say, this was about 2010-11 is when we started really kind of getting into the market, and started talking to a lot of brands with whom we even work today. There was a lot of customers who started approaching us, especially in the consumer packaging space, in the apparel space, global brands who started looking at compostable plastics, bioplastics, and saying, okay, is this is something that, yes, makes a lot of sense to our business, especially for the kind of the quantum of plastics that we use. And so I would say 2010-11 was when we really started getting active business on bioplastics. So the first 4-5 years was more on, of course, we were doing business, but it was very small. It was more into this hospitality space, but there was nothing really too concrete. And then right around that time, there was also a panel created by the government of India, where they looked at saying, okay, how do we kind of look at bioplastics? And this is when they came out. This panel had members from Ministry of Environment, they had members from CIPET, Indian Institute of Packaging, and they came out with a report which spoke about uh, linking the ISO standards, what is the product, and then a very major component in that report that came out was that the thickness regulation, which India was then pushing for in terms of plastics, is not applicable for compostable bioplastics, which I believe even today is a very, very significant legislative mandate that is driving business in India. Because a lot of the applications, if you see, we have to use a minimum of 50 microns or 75 microns thickness, which really is not required if you use it in a compostable plastic. And so suddenly the price parity comes into play. And this, I would say, this has been the biggest driver for compostable plastics in India. And then along with it came a lot of improvements in the mechanism of certification, because again, you had an standard which was adopted by the Indian government as ISO 17088, which now had to be tested. So CIPET kind of got involved into the testing process. So we worked very closely with CIPET as well. Dr. Narayan was involved with it. We had a team here working with CIPET and helping CIPET kind of go through the testing process. They had their own team as well. So we worked together with them. There was a lot of knowledge sharing that happened. Once the testing was set, then we needed a certification scheme for this. So that's when the Central Pollution Control Board got involved and said, why don't we be the certifying bodies here? And so they said, let's start doing the certification. And so based on the CIPET report, they looked at a lot of other data in terms of where you're going to produce, whether that factory is that factory where you're going to produce compliant, does it have all the environmental clearances, and then they gave a certificate. So NatureTech was the first company in India to actually get officially certified by the Central Pollution Control Board. So even today, if you go to the CPCB website, you can see NatureTech as the first company there. So yeah, so it's so I think after that it's been 2016-17 onwards, suddenly there was a lot of interest into compostable plastics. There were several companies who got into the certification. And what I'm really very happy about as we speak in 2025 is there are over 250 companies today which are actually certified. And it was so important that to bring a lot of credibility to the certification, you know, have it as transparent as possible, so everyone who wants to be a part in this industry understands who the manufacturers are, who the sellers are. They have options that they can go to. And you know, the ecosystem has just built so beautifully in the last especially 5 6 years. I personally feel that this has been something which is very fulfilling for me as a person.
And we'll also be getting into, the last, I think we had a conversation a year or two back on the effort that you were making to get all the biopolymer people together. But we'll take that a little later. I did want to talk to you a little more about sourcing and the challenges. So, of course, I know that I think you work closely with NatureWorks. I'm sure you have other sources. How easy or difficult is it to source the right biopolymers, the base level materials in India? And of course, now there is big announcements of people coming into PLA space. Is that a positive development according to you? So talk to me a little more about base materials before compounding, and how easy or difficult is it for you to get the exact spec that you want?
So if you see the majority of biopolymers in India, I would say the maximum consumption is coming from PBAT, which is typically polybutylene adipate coterephthalate. That's the major polymer. Incidentally, several years back, the price of PBAT was much higher than PLA. So a lot of people were trying to use as much PLA as possible, mainly because they wanted to reduce cost. But come 2023-24, PBAT prices really came down, and now people don't want to use PLA as much. They want to use it only if there's an absolute need for using PLA. So it's ultimately, at the end of the day, I mean, I've realized that everything drives, economics is what drives everything. We have to really, we that's kind of what really drives the business. Now, sourcing, again, PBAT capacities are very widely available. You have a lot of companies, as for example, BASF in Germany is doing PBAT, but there are lots of Chinese companies as well who are into PBAT. So there's a lot of capacity available for PBAT. And PLA, of course, there's a lot of capacity available as well. You have NatureWorks and Total Core Beyond, but then now with NatureWorks' new facility coming up, hopefully to come online by Q1 of FY26 in Thailand, that'll add another 70,000. And then, as you said, Balrampur Chini has announced another 70,000 that should come back, that should come in 2027. Emirates is coming up with capacity as well. So there's a lot of PLA capacity building up too in around India and the nearby region. I think today we are in a much better position in terms of sourcing. There is a lot of capacity both from PBAT and PLA available. Now, the right quality of the material, when you said you specifically asked that do they have the quality, is very important, because here is where I see a lot of small nuances. Like, for example, all these biopolymers are very sensitive to moisture. Typically, that's how a biopolymer really biodegrades, because it moisture kind of breaks the polymer. So it's very important to also understand the quality specifications of that initial material, because that can make a huge difference to the performance of the final product. And here I see a lot of differences. Sometimes there are there are not a lot of companies who give you consistent quality. And so here I think it's important for the people who are making those sourcing decisions to be aware of what is really needed. There are lots of PBATs, there is lots of PLA suppliers in the market, but then there's also consistent quality, good, if I go a little technical, you have to have a good molecular weight distribution. You need to have a low acid content in the polymer, because if you don't purify the polymer and you have residual acid which is present, that kind of breaks the polymer when you put it into other downstream processes. And these are like very small things. I mean, even a ppm level of 0.01% of some acid content can make a huge difference in the performance, like a shelf life, for example, of a material. And this is what really differentiates the good quality material from something which is okay but not so good. So I think capacity available, yes, completely there. And then the other question is, what I see is majority of the market in India, I would say, is driven by PBAT and compounds of PBAT, which are either filler based chemistries. So people typically, the major application is a shopper bag, for example, where you could have a PBAT with a 40-50% filler, and this material is just sold in the market. I also feel that as a country, we definitely have the expertise to get into more value added applications. And here is where I come back to sourcing, because you can start looking at polymers like PBS or PHPVs or PHAs, which have very unique functionality and properties. For the present market in India, I don't think these materials can compete commercially in that space, and that's why it's just PBAT, because it is the lowest cost biopolymer right now available. But when we start working on more value added applications is when I think these materials, the other materials, would start playing a very important role.
Of course, you and I are both hearing a lot even about seaweed based polymers
Yeah.
now. What is your take on that whole development on seaweed? And there are lots of young companies coming in and exploring that. Are you buoyant about that? Have you experimented with that? Have you blended in? What is the stage, and how do you see that product growing?
See, to be honest, I we haven't done work on the seaweed based technologies. I know a little about it, of course, but essentially, I think all these materials, um, what we really need to understand is, one, can they give you consistent product? That's one. Every day you have something new coming up, but then is it going to give you consistent product? The second is there going to be availability, or is it going to be something where it's going to be like really niche, and you only have X kind of quantum available? That's the second. um the third is, uh also from a carbon footprint perspective, what are some of the process based footprints when you take some of these technologies and make it into product, which I'm not sure if anyone has evaluated it in the seaweed side. Because today when you talk of PLA, I can tell you that a typical LCA of a PLA would look like, the material footprint would be zero. And then your process footprint of PLA is actually higher than the process footprint of a conventional plastic. But then when you combine the material and the process, PLA still has a lower footprint than conventional polymers. And the goal is you can still work on the process footprint by looking at renewable energies and so many other technologies which we can use to reduce the process footprint. So some analysis has to be done in any of these new technologies. And finally, what I believe is that sometimes these technologies are also they're not the right terminology used. Like, I know I've always said this, many times you've heard of this very famous soap brand in India called Mysore Sandalwood Soap. And to a common consumer, someone would think that, hey, it's made from sandalwood. But if you really look at the ingredients, it's got like 0.1% or 0.2% of that ingredient. So it's also about marketing. And I think a very holistic approach is required. I know there are lots of technologies, someone is talking of this biotransformation, someone's talking of the seaweed. There's also this whole bio-based chemistries which is coming out, like what Braskem is doing on bio-based polyethylenes. So many of these technologies are available. I think a more holistic approach is required to understand the true sustainability of a technology. And maybe I'm not being judgmental, but maybe they are sustainable in certain ways. And we can, all that I'm saying is I think we need a more detailed analysis.
We would like to take a minute to thank our sponsors. Good Garbage is sponsored by Packer, a family of brands that produces compostable packaging and works to implement regenerative solutions. Packer's new project is to bring compostable food serviceware and food carry products to the North American marketplace. Learn more at packer.com. Now back to the conversation. And what do you think of the whole PLA versus PHA argument? And of course, there is also the blending of the two as well happening a lot. CJ, of course, is doing it, and then there are others. And I'm sure you probably have tried a lot of formulations there. So there is, of course, this argument that we have that PLA is industrially compostable, PHA is home compostable. There is the idea that PHA is more malleable, PLA is more brittle. Yes, you can blend the two, but educate us on that idea. Why this debate, and what is it that from a company that is buying a biopolymer, what should they look at apart from the pricing angle? If the price was the same, what would you do?
See, as I said, as NTIC, right, we've been always very agnostic to the biopolymer space. So for us, a PLA or a PHA or a PBAT is just a chemistry. And that chemistry has got certain advantages. The question is, can we kind of use those advantages to build something? So when I say I've never looked at PLA versus PHA. It's always been PLA and PHA. And that's kind of how we need to look into it. Now, they're both completely different biopolymers. I mean, just the fact of, each one's property is different, the way they are made is different, the capacities which they have is different. But I believe that PHAs can add value into PLA systems. We could definitely look at creating certain compounds between PLA and PHA that can bring some good value proposition, like for example, transparency, malleability, ductility into, and of course, PHA coming up with PHA being home compostable. We can also evaluate if at what percentage levels of PHA will PLA also be home compostable. So yes, they're just different chemistries according to us.
And what about now? Let's look at the application side. So you said you started gaining cadence maybe 2011ish, 2016, 17. There's more movement. So what are the applications that you could really step into? And of course, the other one which you brought in is the whole changes with the micron. That kind of added more competitiveness to your products. So what are the application that people took your product in a significant way, size, and like how do you feel they will evolve as you go along? What are you most buoyant about that these are the applications I'm going to focus on?
You see, the way I would like to structure the application is the way I've always looked into it is one, in a very broad way, does the application require a certain barrier? And when I say barrier, I mean either moisture barrier or oxygen barrier, or does it not require that? Now, the reason I want to use this as kind of a dividing point is because barrier has always been a holy grail as far as compostable plastics are concerned. And because it goes against the very principles of compostability. So I'm not surprised that that is the case. Now, obviously, there's a lot of work being done on how do you improve barrier with compostable plastics, which I will keep it separate. But if I look at the application realm, it's very easy for us to say, okay, this application space does not require a lot of barrier, and this application requires barrier. So that's kind of the first differentiation. Now, when I go into applications which don't require barrier, which is more of a low hanging fruit, then the way I would like to again divide and say is, can I use the legislative provisions in the system that allow me to down gauge the material thickness for this application without compromising the functionality or the use of that application? Now, why this differentiation becomes very important is, if I'm able to identify those applications where I am able to now down gauge it, then suddenly my cost is no longer an important point, because I'm coming close on the price. I'm kind of reducing the barrier between a conventional plastic and a compostable plastic. So I've identified this does not require any technical features. It can also be downgauged without compromising on the functionality. Those would be my target application. So if I look at that, my first targets would be, consumer packaging. That's where NatureTech has gotten into in a big way. Apparels, if you see, lot of the apparels, they don't require barrier. There is no major requirement for any puncture resistance. You're packing a shirt, a pant, you don't really require, there's no sharp edges. You can down gauge the thickness. It's a dust protection cover, and it's very single use, so obviously there's so much of turnaround of this material happening. So this could be one approach of understanding what could be a right application fit, and there are several applications like this. Maybe once you if you get in, secondary packaging is another area where I believe there is a huge potential for compostable plastics, because the barrier is already provided by the primary packaging, and then you have so much of secondary packaging being used. Now these materials could then easily be replaced by PLA PBAT systems with a down gauge thickness offering the same functionality. So this is one angle of the application. Then we come into the more technology driven applications where, now you say, yes, I need a barrier. Now here again, I would say we have to understand, okay, what is the barrier you require? And then we can kind of say, okay, is it a very low barrier, is it a medium barrier, or is it a high barrier? And we'll see that so many applications fall into the low and probably medium barrier requirement. And maybe can we look at certain chemistries like metallization, for example, coatings, so many other chemistries which can bring that barrier performance and move the technology realm forward. I think the biggest learning for me in the last 20 years, and I've really done so many things which I shouldn't have done in terms of going after applications and markets and spending so much time in working on things. I've learned that number one, cost or price is going to be the primary driver. So while we talk on sustainability, we talk on circularity, everyone loves it, but I think no one is, maybe couple of percent premium, but nothing more than that. That's one. The second is that we don't have to go after the entire market. And it's so easy because when you're starting this business or when you're initially getting into it, like every application, you feel that, yes, you can do that. Oh, I can change this, I can change this, I can change that. Everything you see, you are so excited that you want to change it. But then what you'll have to really understand, and what I have understood in 20 years, is that you have to learn to say no more than say yes. And probably that's my biggest learning. And I think, yes, there are a few applications where we can focus on, where I think compostability adds value. And then the final point in this is that I'm also a strong believer of partnerships between material spaces. So, you know, you have paper chemistries available, you have paper, you have jute, you have cotton, you have fibers. I strongly believe that compostable plastics can work in collaboration with these technologies to build better products. And it's not just about the compostable plastic alone. Many times we will realize that these products like paper offer so much more in performance at such a reduced price as compared to compostable plastics, that it's so important to know how to combine these technologies to be able to give a better product. So being very open and not trying to force fit your technology into every application is has been my learning in the last 20 years.
And I couldn't agree more. Focus, ability to say no to many, many opportunities definitely is the holy grail. I have a side question, and you and I know, we both tried to tackle this one together. Is the whole idea of the Indian weather conditions, right? So something may be industrially compostable, and but India is industrial compostable friendly in the sense that Chennai weather is more or less the
Yeah.
same condition as an industrial composting site. So, have there been challenges for you? And what you and I have talked about, sometimes the material might break down in the shelf. And that's a challenge because, of course, we are trying to reduce the gauge to be able to be price competitive. but that also means that there is a challenge in terms of the longevity
Yeah.
of the product. So, have you had those challenges, and how are you dealing with the ideas around that, where somebody wants to use it but can't have the material exposed on a shelf, for example? So, how do you tackle something like that?
No, it's a very valid. Very valid question. I think that's why there are certain applications where you have to be able to say no, that you can't do this. And I know some customers come and say we want a 2 year shelf life or a 3 year shelf life, and we'll be like, no, it's not possible, especially in the present humid conditions that typically we see in India and around Asia, I would say. But having said that, there is a certain shelf life that we know what is there for the material. And here is where I strongly believe that using the right polymer chemistries, the right raw materials, the fillers at the right amount, which does not break down the polymer quicker, becomes very critical. And I can tell you a very classic case. When COVID hit in 2020 March, I think none of us were prepared for the lockdown. And we had a lot of customers in the apparel industry where products were being shipped out. There was inventory at the customer site, there was inventory in our warehouse, there was work in progress production going on, and everything was suddenly shut down. So for about 3 months there was complete closure. Now when we came back into operations, we were very pleasantly surprised to see that our products were still holding up, and a lot of our competitor products were actually breaking down. So I think that was one time when we really were able to find the value, and the customer was able to realize the value, because no one in a regular business day, no one has so much of inventory. It just keeps, it's all rotating, it's going through, and then no one understands the value. And then when you go to a customer and say this will have this value, they don't realize it. But when something like this happens, it really makes a difference. So in India especially, we have to be very specific in terms of what is the integrity of that product that you bring in from a technical perspective. Now, for example, there are lots of applications in the thermoforming space here, where typically when you do thermoforming, you have almost 40 to 50% of material which is wasted, and this 50% gets reground and added back. So the more you're able to add into your virgin polymer mix, your cost keeps getting reduced. Now here again, our formulations, what we have seen is that with NatureTech formulations, the customers are able to add more of regrind into it without compromising the properties. So sometimes, and this is what I always tell the customers or even our sales team, is it's all about value selling at the end of the day. Many times customers tend to look at the price from a very unidirectional standpoint, but when you look at the total cost, including what you can add, the scrap, the wastage, it kind of becomes a lot more effective. So answering your question, I think the Indian conditions are pretty aggressive: high humidity, high temperatures. So we need to be very clear on the chemistries we use. We have to use materials which are stable, which can at least give you that required shelf life. And a lot of the fact also remains in terms of the packaging, like you have to keep it stored in a certain condition. So we have very well defined SOPs for how those things happen.
What about other set of properties? So, of course, you're trying to compete with the material that has been there around, sort of optimized over time, etc., etc. What are the few other set of properties that you find that is a little bit of a struggle? It could be stretch, elongation, tensile, runnability on a machine. It could even be issues with getting into the form or blowing. So tell us more about a few of the things that you have maybe struggled and overcome. That these are the properties that were a real challenge because I was competing with the existent polymer, and this is how the challenges were overcome.
I think conventional plastics are probably so forgiving, according to me. they are like, you can beat the hell out of it and still, they will just do the job. I mean, they're just so beautiful. You can, they mold it, shape it the way you want, lowest cost, stays forever, so no problems for shelf life. I mean, it's like a dream for anyone to have it. So it's going to be very difficult to kind of reach that. And I always feel that, as people who are developing polymer chemistries, we always want to say, okay, I want to be exactly like that material. And probably we need to kind of revisit that thought process a little bit, to say, okay, instead of saying I want to be exactly like that material, can I work on an application which allows me to meet the requirements? And that's how the thought process needs to change. And sometimes these materials are very over engineered for a certain application. And just because, and I know you know that as well, many times a lot of shelf life or functionalities or other properties are based on conventional plastics, and maybe the application really does not need that kind of a property. So that's one. Now, coming to a specific case, like what we've personally done at NTIC NatureTech is, PLA. Again, I go back to PLA. PLA is it has a very low heat deflection temperature. So it pretty much softens at 55, 60 degrees. You can soften. So when we started working on saying, okay, how do we kind of improve the heat distortion temperature of PLA? This is when a lot of, you would say, technology interventions were put into place, where we were able to develop a compound where we could improve the heat distortion temperature of PLA up to about 85 degrees without compromising the compostability of the polymer. So this was a very, I would say, strategic and a very critical kind of development that we did as a group. And it involved a lot of trials, both at a compounding level as well as, the molding, making the product, testing it, what conditions do you run it, how do you improve the crystallinity of this polymer, how do you improve the heat distortion. So there was just a lot of work done, and I'm very proud and happy to say that as NTIC, we've really, we did a lot of commendable work in this. We have a proprietary position in this space as well today.
So continuing with that chain of thought, so most of your R&D is still happening in Minnesota. And how does that, like one of the things that from a personal standpoint also has been a struggle for us as we go more global, that one, many times it's difficult to translate the challenges of one geography to another. And many times it takes time. So we are actually trying to right now decentralize a lot, where we are saying that, okay, let's work more as SBUs. And more or less the product development can be at that location. And then there is a central, more of center of excellence R&D that actually does more what will come 2 years, 5 years, 10 years hence. So educate me on this, like how does it work with your R&D center in Minnesota? Are you guys able to turn things around quickly, or there's a lot of work that you do in Chennai and then complement it from the work in Minnesota? Is that a smooth process, or is it a bit of a challenge and you guys are also struggling like us?
I would say what is very important, what we've been able to understand is, as you rightly said, each and every geography has a very specific requirement. That's one. But having said that, there are also certain commonalities we can see across geographies. So one thing that and like every other company, I think we are also in the same process of learning, unlearning kind of things. How do we do this best? I mean, it's a process. So we have different teams in different countries right now who are executing the business, but they are also coming up with capabilities where they could develop applications. So I'll take the example of India. Now, in India, we have a team who can work very closely on the application side. And so let's say we have a customer who's interested in a certain application, we can actually work very closely with the customer. Now, we take that application back to the US, and then if we have a consensus that, okay, this application demands you know work from our team, whether it's the potential of that application or if that application has a common thread which can be used in other regions as well, then we take a call, and then the team in the US starts supporting us in the development of that application. So the work is very clear. A lot of the back-end work is done in the US in terms of materials, characterizations, developing initial maybe trials could potentially happen. And then when we come to a certain point where we say, okay, from this lab scale, we are ready to move into a pilot, then the local team in India would kind of step in and start working on that application and seeing how we can take it forward. So it's a lot of very, very mutual collaboration. I think at the end of the day, it's about having one platform, one strong guiding platform to focus on. And each one of us in different regions believe that yes, we are, although we might, our business might be in that region, we are still part of a larger organizational group where there could be multiple interests. And sometimes we will also, we are being, sometimes we will be told that no, this, maybe this is not the right time to get into this application. Maybe we don't have resources, we are probably doing a lot of stuff right now that we need to get things executed, let's finish this and go. Or maybe we find that this potential is not so big, it's very focused on one geography, maybe let's focus on other things. So it's a it's a very open dialogue that happens between the teams, and then we collectively decide what we want to do.
Yeah, that's good to hear because it's always a challenge to do prioritization, right? Because everybody, like each person we talk to, we literally, like I'm personally involved in product development on a weekly basis. And, but then, like I find that people, especially in different geographies, are constantly frustrated because they want something yesterday. And like the team has to ultimately prioritize again, like you said, there's a certain size we have, certain cadence that we can have, and of course we fail and we succeed, and you fail again. So so it's interesting that you guys at least seem to have a relative balance. You were very complementary to what we would call in traditional terms competition. You said there's a lot that has come in, you even give a number of companies. So how are you seeing that? Because I presume with this influx of people, because everybody will try and survive, there would also be maybe unplanned cost cutting. Like they might quote a price which is going to kill them, but also disturb us in the process, right? So how are you seeing this influx, heavy influx of people, and especially the whole sustainability space catching a lot of fancy? And I guess barriers of entry may be relatively low if you just need to put a compounder and buy some PLA, buy some PHA, buy some PBAT, mix it up, and like you're good to go. So how does that affecting the industry overall? Like when you spoke earlier, you said that fundamentally it's a good inflow of companies, but do you also see downsides because of that, of heavy kind of interest and people coming in without maybe having the depth of knowledge that is needed?
See, the way I look at it is, I think from a long term perspective, I think it's positive. Maybe the downsides are more short term. What I again feel is, when we started this business in 2005, the bigger concern was, how is the market going to develop? I mean, there were like two people, two companies, and then for a good, I would say till 2017, 18, there were hardly three, four companies in the market. So you had that real fear, or whatever you want to call inside you, saying, is this market going to evolve? So from that perspective, I think it's very positive that so many companies have come in, that now I feel the market is definitely getting evolved. That's one. Second is, from a legislative standpoint, it's very positive because 10 years, you are one of the very few companies, and now you have an association, you're doing things, there are so many people involved. Balrampur Chini coming in builds a lot of credibility as well to the market. So that, I would say, is positive as well. In the short term, for a company like us, obviously we are faced with a lot of pressures, competition in the market. There are lots of guys coming in, you know cost cutting, giving you products. Obviously compliance becomes a challenge. But I think, what I personally believe is, if our fundamentals are strong and we are able to build the right compliant product and the right solution to a customer, I think in the long term, definitely the customer is going to find value. Maybe in the short term, the customers could probably, switch, look at options, go after things, maybe understand, explore, which is absolutely fine. Uh, but I think we still need to stay very, again and again, stay focused on what your product can do, and want to make sure that you build that ethos into your working, and continue to stay there. And like every company, yes, as the market is growing, these things are bound to happen. So it's like a part and parcel of the daily business. But I'm very happy again to say that I see today 250 companies certified. Um, it's putting a lot of personal confidence that, okay, we are in the right industry. We are in the industry where things are growing, and this is where, as nature tech, I think we also have the ability to develop good applications in the industry, which can create a lot of value. I mean, a lot of the people are looking at kind of me too applications like carry out bags, garbage bags. But if we can go in and develop good applications, good, strong, technically sound, compliant applications, I think there's a tremendous potential.
That's great to hear, and that places us well on the conversation we had on Bioplastics Association. So tell me more of the genesis of that. And I know you've kind of led it from the front and been one of the initial kind of people who have really pushed towards that. And of course, and in conjunction with that, of course, we both know how much policy matters in this space. So, what has been your experience in forming this association, bringing people together, and then really are you seeing certain traction happen in terms of policy making and sitting on those tables to be able to influence that?
This association, which was formed in, I would say, 2017, 16, 17 time frame. At that time, there were only about 5 to 10 companies who were part of this association. And what we understood was majority of those companies are more process industry players. Of course, there were raw material folks like BASF there, but there weren't too many raw material guys. There's more driven to process, in terms of there were all these guys who were making either films or making injection molding or certain components out of it. Now we push back to 2025. Suddenly the ecosystem is got a lot more players. You have a lot more raw material providers. You have one company who's going to do it in India, but you also have PLA coming from different sources. They want to participate. You have PBAT guys coming in. You have the process industry. You have the brands and the retailers who also want to be a part of it. So what we are really trying to do is we are trying to reinvent. So this association, what is ICPA, which is Indian Compostable Polymer Association, we are in a journey right now to rebrand it as Indian Circular Polymer Association. So change the word compostable to circular, and then you start talking about bio content, you start talking about end of life, you start talking about bringing in players from the other industry like paper, for example, to kind of participate in it. And interestingly, this process is we have started this process of rebranding and I would say structuring the entire association. We are going to be creating a lot of value chain groups. This could be, raw materials is one. We could have a process. It could be a compounder, film producer. You could even go as backend as a farmer, for example, in the value chain, or you could even come into certain, industries like, for example, waste management guys, right? People who are doing the waste collection, brands, retailers, and then we want to have a certain program in place where we have a good representation from all the value chain groups into the executive committee. And this executive committee will then have a professional team of members who will then appoint an executive director and a certain operational team to go and execute the whole thought process, the vision, and and kind of take this whole association forward. So I'm very happy again to say that we are progressing well with the Indian Circular Polymer Association. I believe in the next 3 to 6 months we should have this. We are in right now creating some structures. We are creating the mission, vision statements, the documents. Everything is in progress. The website is being redone. So I think in next 3 to 6 months, exciting times. Looking at bringing in more new people, more new thoughts, So yeah, so that's kind of how I've been involved as part of it.
Yeah, this is a conversation we had, what was it, a couple of years back, where
Absolutely.
we literally pleaded, let us in, and you were like, no, it's only bioplastic. So I'm glad you'll finally let us in and
Yeah,
let us sit with you on the same
absolutely.
table and learn from you more. So thank you for that. I'm glad that that's been the evolution, because I do feel that we are all, like you said right in the beginning, we are on such similar journeys that if more of us combine, then there is a deeper thought process that may emerge. And also I think there'll be more collaboration opportunities that will happen, and like you said during the conversation, again, in different materials as well. As we sit on the same table, there will be more opportunities to coordinate and combine different materials. And again, the second part of my question: are you seeing a certain traction in the policy space because of this effort? And then would you say that there will be a deeper impact as we gain ground on this, on the rebranding and enlarging the association as well?
No, absolutely. I think we are definitely seeing a lot more traction on the policy side. I think a lot of that has also been the fact that the industry has grown. Obviously, the process industry in the compostable space has really grown well, and there's so much of awareness right now in the market. So that's one. The second is, I also believe that this association has got a very important role to play in terms of providing the right information to the policymakers. And I sincerely hope that the elected members of this association, this new association, which is the Indian Circular Polymer Association, will be able to provide right insights. Because the one thing we don't want to happen is, we don't want this association to go and tell the policymakers that compostable plastics can solve every problem in this world. And that's fundamentally my worry, you know and this is why we need to have the right people run the association, because a lot of what we say is really what comes back to us. And many times I find that these plastic bans that happen in the country, in different states, could have probably been more well thought of. you know it could have involved probably a better understanding of what is the alternative, what are some of the requirements that we need, what price points are we going to have there, and then come out with a very phased wide approach if you're really serious about implementing it. But when you ban something without having a right alternative, that's really, you're banning it on paper, but it's not really getting implemented on the ground. So this association will have to provide lot of inputs very transparently to the policymakers, to say, this is what as an association we can do, here are what our members doing, this is what it is, this is the products, these are the technologies, this is what we can solve. And then work with the policymakers to bring out the right policies. So this, according to me, is going to become critical. And if this happens, I definitely think compostable plastics are there to stay, because then you're building an industry which, if implemented, can provide value at price points which are affordable, and work on technologies which can give you again the right properties which are required for an application, and the ecosystem is well built to service that.
There's only one kind of difference in thought, I would say, that I might challenge you on. So a couple of things. Let me take a step back. As PACA, our dream has always been that when we tout on the policy side, it's been that, like, as humankind, in an ideal world, we should have a single dustbin, a single trash can, and ideally it's trapped energy, so everything should ideally be converted to gas and then composted. So that's the dream we dream of when we look at our kind of policy inputs. That how does humankind go towards that? That every packaging, every food waste, etc., yard waste, everything is converted to gas and compost. And everything is capable of doing that, which is single use at least, and it all goes into that single trash can. That said, the second part that you said, I agree with you on a idealistic world where we go step by step, And then, like, if there is only, even it's the scale of material as well, right? You might ban it and you need so much material, it can't come overnight. So again, there's a challenge, then people find escape routes. But what I've also noticed, and this is where I would like to get your view on this one aspect, is that when there is a drastic ban, there is a sudden speed of innovation that happens, right? Because people know that. I remember this was 2019 or something, and there was this rumor, you'll remember, that on Gandhi Jayanti, there's going to be a plastic ban. So that everywhere I went that year, you would find a bunch of Indian companies, right? They are all talking in Europe and US, wherever you go, they're all trying to find solutions. That ban didn't happen on Sector in October, and it was dead, right? And then, of course, it came in 2022 or whatever. So, how do you see that part? How does one balance the two? You still need the speed and the urgency so that people are working towards it. But I agree with you. You don't want to have a ban which you can't execute because you don't have alternates.
No, and look, it's a double-edged sword, to be honest with you. Um, but what is more? Let's talk a little bit about what is more critical here, right? When you have a phased ban, it's that the government announces before that this is what we are going to do over the next 2 years or 3 years. I think when the ban actually happens on a certain product, you are able to make sure that that implementation is successful. And what that would also do is that would give people the time to work on saying that, okay, next, if this is going to get banned or if the government is already looking into it, can we work on it? The challenge that we all face in India is, the ban happens and then we start looking out for solutions. So that's why, and ultimately it's the see, the businesses have to run, right? Wait, so what happens is, uh, the guy who's going to pack your vegetables, he is not going to he's making, 300 400 rupees a day. He's not going to pay 2x or 3x the price for a shopping bag. He's going to buy, maybe if he's using 1,000 bags a day, probably buy 50 bags of compostable, and the remaining 950 bags he's just going to buy of conventional plastic, because you have not thought through what those guys are going to use. And here is what happens is, when this process starts going, then the real product actually loses its value in a ban like this. Then you don't have anything going forward. You're not able to implement anything because people have already moved on. They're not ready to accept your product because they just have. But if, for example, you do the back end work and say, this application, garbage bags, for example, so many households require, this is my thing, I'm giving an incentive, I'm creating some value for bringing in compostable, and then you educate the person who's going to use this to show him what that incentive is, the person will be more open to going and buying a compostable bag. So again, there's no right or wrong here. It's just how we look at it. Maybe in some way a blanket ban is also good in certain ways. I'm not saying it's completely bad, but what my experience has been, and I've been through at least 4 or 5 bans in the last 15-20 years, uh, sadly it's not been successful. That's really. And even today, I don't know if you are seeing it, but I can see a lot of conventional plastics in the market in India. There are about 18 to 20 um, items which is there on the plastics waste management rule, which is potentially restricted, but I really don't see a huge implementation of an alternative in that.
No, absolutely. Totally agree with you. And I like your idea of what you're saying is that have a very clear phased approach so that there is a time for everything rather than just it's being blanket. Because you're right, it's really available. It's not even like somebody's hiding. You go to a vegetable guy and that black colored thin, whatever, 10-20 micron plastic is free. Like there is nothing stopping them. They probably have to make sure that the police guy is happy, but
Yeah,
that's really it. It's just added a little cost for
yeah.
them and hassle for them. So you're right. I like that approach overall. So just looking at the future now, a little bit of crystal gazing. What are the ideas that you are most excited about? You're so well kind of enmeshed in this space, and I'm in particular interested in the base level polymers. So, of course, you have a fermentation process, both a fermentation, whether it's PLA or you have PHAs that are coming through, some kind of a microbial multiplication. You're seeing these seaweed extracts. I've heard of different amino acid protein based whey protein, and then you have various others which are in the fringes. Are there certain base polymers that you are getting more excited about, or you feel that in the next few years they'll be developed? And then combined with that, are there certain products that you see that, okay, this is going to gain cadence in the next 3 to 5 years?
See, I think from a base polymer space, I am really not sure what more can be done. Obviously, you know, we've covered the PLAs and the PHAs and all these different chemistries. Maybe copolymerization could be something that can be explored, but again, it's looking at different monomers and trying to look at what you can build. What is really going to drive a lot of development is on the application side, and this is where I feel the base polymers that we have today is not fully utilized. I feel there is a huge gap between the application and what a base polymer can give, and there's no matching. So there's a lot of mismatch where I feel there are lots of values that a base polymer has which is not even being thought of. See, I'll give you a example of 3D printing. Right now, PLA is actually one of a very good polymers for 3D printing. The reason it's really good is because it provides good low energy when you do the printing. The efficiency of printing is good. You can print very intricate parts where you require a lot of high resolution printing. And incidentally, PLA is sold in this segment purely because of its functionality. No one talks about sustainability. And so here is an attribute of PLA, and this is what I meant by understanding what a base polymer can give and the application. Now, when you look at PLA, incidentally, no one would really think about, saying, hey, is this going to be used for this application? What's the value it's going to give? And everyone is talking about, okay, PLA means it's a bioplastic. We have to use it to show bio content. We have to use it to show compostability and things like that. So this is one area where I feel there's a lot of things in future that can be added. And the other thing is, a lot of biopolymers have very good breathability. So I still think there are several applications where the breathability could be used as a performance attribute for enhancing the performance of the biopolymer. I feel there's a little bit of research that's happened here, but there's a lot more that can be done in this space. So from a base polymer perspective, I'm not sure. Again, there is always developments that can happen, but I feel that whatever base polymers we have, there's just so much more to do with that, which we are not doing.
So tell me a side note. What percentage of Sundar is still a scientist, and what percentage of Sundar is a business guy now?
So if you ask me, I would say about 80% is business.
I would have imagined that.
Yeah,
When you're kind of trying to build something, it becomes what, right?
yeah.
The you have to rely on others
Yeah,
to do the
but the
science
good
there.
thing is, I think because I'm just so inspired by this whole field that I think there's a lot more things that we could contribute in terms of the science behind it. I personally believe that, and hopefully my aim is also to have over time to be able to spend a little bit more time on the innovation part of the piece. So I hope I can do that, and I'm confident that we are building a team here who could then kind of run the show. Yeah.
Yeah, I'm struggling with the same. Too much time is being taken by business. I would rather spend
Yeah,
more time on the products and
and
innovation. So hopefully we can go tag team.
yeah, and I also think Ved, a lot of it is also got to be with how I feel. I don't know if it's there in you've worked in other countries as well, but I feel doing business in India is a little bit more difficult just because things are changing so rapidly, and we almost have to be like, I would say, on the move like 24/7, trying to because someone is doing something behind you, doing something here, something there. So your mind is always thinking, who's going to do what, right? I mean, you don't have time to say, okay, this customer is set now, let me step back. You can't do that.
Yeah, yeah, and you're constantly hustling. In fact, my wife says you're a misfit for India. Stay away. Like you'll just disturb things in India because you're thinking too idealistically.
Yeah,
Step back.
yeah.
So that's what I try and do. I have thankfully I have great people with me, so so they manage India, and I can just trouble them instead of instead of trying to step in directly. So that's where I am. Okay, just towards my final two. So if you were again to look at growth in the next 4 to 5 years from a nature tech perspective, what would that look like for you? And you can choose in terms of tonnage or in terms of revenue, whichever way you want. If you had no barriers in terms of product availability, and you were able to get more market acceptance, what would your dream be that in the next 5 years I would like to build this to this many tons or this much revenue?
See, I think nature tech in India right now, uh, you know, I feel, over the next 5 years, if we are able to grow the business at about 20 to 25% year on year, I feel that's a good target to shoot for. I know it's definitely a stretch, but what I would also like to see in this growth is I would like to categorize it more in terms of how diverse we are building the application realm, because I feel the actual growth in terms of tonnage and value is one, but growth in terms of, are you diversifying your application base? Because today in India, majority of the applications are very kind of factored into certain specific products like carry bags and garbage bags. So, or straws, for example. So, can we diversify the application base? That's one. That's going to be a very important metric. The second is, we are looking at geographies outside of India as well. So, Nature Tech India, we kind of look at Southeast Asia, a little bit of Middle East. So, the other important component is, how do we build the right partnerships in these different geographies to be able to position ourselves for growth in those geographies. I think this is going to become very important for us. And then the third is, from an average selling price perspective, are we creating value in terms of the applications we are going in, and how is that changing over the next 5 years is also going to be an important metrics which will determine what are we getting into. I mean, we could still grow 20-25%, but it could just be in a segment which is already there. So I think it's a combination of all these different parameters, but I am very bullish about the nature tech space. What the way we are positioned in India, at least we have a very strong fundamentals which we have built in the organization over the last 15 years. I think we really like to stick to what we believe in, and we would always like to be a very transparent partner to all our customers. I mean, that's something that I'm investing time in building a team which can kind of look into building that transparency. I mean, we never want to come out as a supplier who wants to just get business. I mean, if there is a better opportunity for our customer, we should be the first people going and telling them. They shouldn't hear it from someone else. And this is something I personally believe in, because I believe in this is what builds the relationship. Business is only a part of that relationship. It's not everything. So I think I believe we have the fundamentals strong now. Again, we'll have to just wait and see how the market evolves.
That's, I think, really well thought of, and I like that you parse it in three kind of buckets of growth in the next 5 years. And to tell you, Sundar, from my personal interactions with you, I don't think you have it in you to be a pure kind of transactional businessman. You'll always look
Thank you.
at it from a perspective of how can we build. That's probably the scientist in you as well, and the person in you as well, where you'll always look at, okay, how can we better the application, how can we build better for this person or with this person. So that's at least all the interactions that we've had in the
Sure.
past few years. They've always been value added, and conversations have been rich, like, okay, how can we do this, try this, etc.,
Thank you.
etc. And that takes me to my final question: what does good garbage mean to you?
For me, I think so. I'll first talk about good garbage, but then I'll also talk about this specific, podcast that you've been very passionately doing. For me, I think when I started watching your podcast, and I've been following your podcast for quite some time now, also been following all your posts on LinkedIn. So whenever I see a new post, I kind of make sure I put some time to make sure I read it when I'm in a calm and a cool, because there's so much of information that comes into that. um it's uh, it's an amazing concept in terms of building value. It's all about creating value. And for me, just because we are all in the same field, the word garbage is typically construed as something that is no value. And it's all about understanding what value you can create from it. So every different waste has a certain value. Now you might not get every value out of every waste, but there are certain specific values that you can bring. For example, if it's an organic waste, you can definitely create a certain value. If it's an inorganic waste, it can be different value. So what I believe is that this series, what you are bringing, these different thought leaders who are coming and being a part of this, is is giving a lot of different focus, different vision in terms of what all you can do differently. And this is what I've learned a lot from these podcasts. I personally, I've I have I would say really inspired by hearing some of the thoughts, and I know, in my interactions with you as well, Ved, I've always been inspired by what you have been able to do as a person, as a company. And I know that you have taken a lot of decisions in your life, which is kind of very fundamental to what you believe in. And so I think I feel that this whole concept of good garbage is something that resonates deeply within you as an individual. And that's why you're able to bring this out so passionately. I don't look at this as a series, where someone is talking, you're asking questions. It's so natural, it's so beautiful, you're so open to each other about it. I think that's the beauty about this whole podcast. And to be honest with you, I didn't even feel that today this is a recording, right? I'm just like, we're talking, we're on a video call, we are chatting, that's about it. So yeah, it's been great. I just want, if we can probably look into similar systems, similar kind of thought processes across different industries, I think it would be really good. Because I don't see, I see a gap between what people want to speak about and the forum in which they are talking about, right? There's again a gap there. Many times you put questions, and today, I know Nurup had asked me, like, is there any question you want Ved to ask? And I said no. I said, look, I'm going to talk to Ved, and that's the beauty about this podcast, right? I mean, we are just so natural with each other. So I really enjoyed, and it's always a pleasure to connect and talk to you.
Oh, thank you, Sundar. You're very, very kind. So you are my that one download that happens sometimes. You are the person. Then I know. Otherwise, it's all for my consumption. I get to learn from people when we talk to each other. But no, it has been really kind, and I'll also tell you from my perspective, I think this has been such an enriching journey in the last couple of years, just to be able to talk to people so openly. Because you're right, we are just having a conversation, and it could be a video call. We've had a few in the past, and we just chat, ideas, and that's the beauty of it. That, like, each of the persons that I've met has been so open with their ideas, and I've learned so much. And I keep thinking that it's somewhere stored in the ROM, and thankfully, hopefully, it'll come out at the right time. So yeah, it's been a great journey. But more than that, I know, Sundar, you're very, very understated, and you've always been like that. It's the Tam Ram quality again. But I know that you're transforming, at least India in many, many ways, because I see your products and I feel really happy that, another Nature Tech product is visible, and, you're trying hard to build this. And I know it's been a challenging journey, but you've been at it. So thank you again for taking the time, for chatting with me, and of course for the work you do. So thank you so
Thank you.
much.
Thank you. No, it's a pleasure, and look forward to meeting you soon.